Hello world, it's Siraj, and today I want to talk about blockchain for supply chain management. In this video, I'll talk about the market for supply chain, how blockchain can affect it. I'll demo this app that I've compiled and I've run locally called Asset Tracker that uses Solidity to create an asset on the blockchain. This is on the test RinkB Ethereum network, and I'll talk about how that works. I'll go over the only legit blockchain supply company that I could find called SyncFab, how they work, what they're doing with their version of an ERC20 token, and then I'll code out in Solidity an asset tracker that runs on the Ethereum blockchain. Okay, so that's what we're going to do in this video. We're going to create a decentralized supply chain app for asset tracking. Okay, so the supply chain industry is huge and it's only going to grow over time. So the Americas, Asia, Africa, right? These are all markets that are big, and the developing countries in particular, particularly on the coast of Africa, are going to grow exponentially over time, and parts of Asia as well. So the supply chain industry is not going anywhere. It's been around for a while, and it's here right now, and it will be here in the future. And so this is a very big industry. And for those of you who don't know what the supply chain is, whenever you are the path that any product you have in your home, your shirt, your desk, your computer, whatever, it follows a path of intermediaries to get from the factory where it was created to you. And that chain includes distributors, it includes procurement officers, people who are quality inspection officers. It goes through different channels, right? It's not just like direct from manufacturer to the end user, the consumer, right? There's like 4 or 5, 6, sometimes, a dozen intermediaries in between there. And that process, a lot of data can get lost in that process, right? Some quality assurance person could say, well, I thought that it was going to come yesterday, but it didn't. And someone delayed a shipment from this city to this city. And so that kind of error just trickles throughout the entire supply chain and can ruin everything, right? So there are big problems with the supply chain. But what I found very interesting is, in a survey that a bunch of professionals, C-level professionals, were asked, what is the aspect of digitization, hilarious word, that you believe will drive the most value in the future? Most of them said supply chain visibility, right? So usually you don't hear that much about the supply chain when you're thinking about applications of blockchain. You're thinking about banking, you're thinking about, perhaps real estate or betting or gambling. But I believe that the supply chain is, as of now, the biggest industry for blockchain. Like, this is where the most immediate real world use case comes from, right? And the reason is because there's so many problems with the supply chain as of now that blockchain could help fix. So let's think about all the ways that the supply chain is wrong, right? The supply chain is suboptimal. So one would be ocean freights, for example. They account for 90% of goods traded globally. That's a huge number. 90% of goods traded globally enter an ocean freight at some point. Now, the problem with ocean freights is shipping information usually travels through numerous companies and contractors. This can cause a delay. And remember, a delay anywhere in the supply chain not just costs time, it costs real money, right? Because these intermediaries are all right now trying to predict what day something will come to them, the product, and when they can then inspect it or whatever their job is, and then they can send it on throughout the rest of the chain. So there's a lot of problems here when it comes to planning and forecasting, asset management, visibility, procurement, manufacturing, financials, right? There's a lot to keep track of, right? For at least for one company. But the problem is when it comes to supply chain, there's not just one company involved, right? Ideally, if I wanted a desk, I would just go directly to the factory, or I would ping the factory and say, I want a desk. And then that desk could just be drone shipped over to me, and that's it. But that's unfortunately not the way the world works. There's a lot of intermediaries there, right? How much are you supposed to pay a driver? When are they supposed to know when a certain product has been shipped? How can all of them trust each other to have done their job? Right? How can the driver trust that the package was delivered at this point? How can the consumer, the end consumer, know trust that the product that they're using is an actual quality product, right? Because if all this data, is stored in a database on a website, any of the intermediaries could easily modify that data, right, to fit their best interest, right? Because remember, there's not one company in the supply chain, there are multiple companies. So the problem is that they all have competing interests. So you have to trust all of them. And this is a problem, right? Because any of them can just modify something and say, oh, you know what, the date for this product was meant for this day. And then the other person will say, no, we had a deal. And they'll say, oh, well, look at the database. And they changed it. And you just have to go with that, right? Because you can't, you just have to trust them as of now. And this is a problem, right? And that's just based on trust alone, right? So trust is a big problem when it comes to supply chain. All of these intermediaries with competing interests, these businesses, have to trust each other to create this cohesive chain of operations to get a product from the factory to the consumer. So there has to be a better way. And that's just one problem, right? There are other problems. It's difficult for small businesses to get into the game, right? Like if you're a small business, usually manufacturers only want to deal with big companies. Why? Again, it comes down to trust. There has to be some reputation. Because these big companies have been ripped off so many times, they want to trust a larger company with a huge history of clientele because they have to, or else they would lose money. But as a small business, you don't have that reputation. Number two is that there's an opaque procurement process. 31% of buyers cite finding the right manufacturing suppliers is a standard issue in the production process. Okay, that's another one. Outdated technology, right? We're talking about decades old systems. Some of these supply chain services are running on MS-DOS. Yes, really. Little to no IP protection. That's a whole nother can of worms, right? IP, intellectual property. Who owns what? When was something created? Who's putting a timestamp and a creation stamp on what? These are stamps that should be immutable, and right now they are totally mutable or modifiable. So the solution to this is the blockchain, okay? And I'm surprised that there aren't more companies that are using the blockchain to make the supply chain process more efficient, right? This is a huge opportunity to make a business, right? This is an opportunity to create a sustainable business using blockchain technology, supply chain. There it is. Now, because there's so many different sub-applications within the supply chain industry, right? Digital ownership, who owns what? Proof of origin, did this crop was this crop organic? Was it handled properly? Who handled it? How many intermediaries did it go through? Trusted maintenance tracking, did this product go through these specific intermediaries that we wanted it to? Did it go through this quality assurance process we wanted it to? Did they water it? Did they peel it of anything that it didn't need, if it's a vegetable? There's a lot of things that, there's a lot of issues regarding trust that all these intermediaries have to deal with. So what a blockchain can do is, if we think about a blockchain, it is an immutable ledger, okay? So think of it as like a huge column of transactions, right? Like an Excel spreadsheet. The best part about a blockchain is that nobody can modify it, right? Once it's been created, no one can modify it. It's read-only access. It's a read-only data structure. Now, this is perfect for the supply chain. Once one intermediary does their job, they can send as a transaction that data to the blockchain. Then the second intermediary knows that this person time-stamped it on the blockchain. Now I know, whatever this person did, and then they'll do the same, and then that just keeps going. And when it gets to the end consumer can say, where is my product from? And rather than having to trust the label on the product, they can literally look at the blockchain and it will show the history of where that product has been. But that's just for the consumer, right? We can think about the retailer, we can think about the store, we can think about the third-party logistics companies. All of these intermediaries can benefit from the blockchain, like using the blockchain in this case, right? The logistics companies are notified of the origin of a product. The retailer gets to add updates to its data records automatically because it's listening to the blockchain. A store has full transparency on every single delivery order. There's a lot there. Consumers can just scan a QR code on some product and immediately know where it came from, which is a perfect use case. But the problem is that not many companies have done this well, by the way. There's so many companies that say we are supply chain for blockchain and they don't actually have any customers or clients. But I found SyncFab, and SyncFab seems pretty cool. If we go to, let's see, blockchain documents, and then in the presentation, let's see some of their clients, which I think is very, very cool. They've got some governments here, which is very cool. They've been working with some governments, the city of San Leandro, city of San Francisco, and some other ones. But yeah, these are real clients that this company has been tracking for years. They've been working with these clients for years. And yeah, I think that's pretty cool. So if you want to look at a real world use case, it's SyncFab. Manufacturing, supply chain, blockchain, very cool stuff. But right, so instead of having multiple versions of truth, right? Remember, these companies are all silos with their own databases. What if there was one single source of truth that they all had to listen to, right? This is the source of truth, immutable, it will never change, it records everything that happens across the supply chain, and you can read it and you can look at it and it will never change and you can trust it. Why? I've gone into that in other videos, why the blockchain is immutable. Just YouTube search Siraj blockchain decentralized applications. That'll get you the first link. So how is a real world application like SyncFab actually doing this? What are they doing that makes that gives them the ability to have clients and build an actual business around this, right? So if we think about the manufacturer and the buyer, right? So you have a manufacturer and they create these products, and then you have the buyer, they're buying these products. What incentive does each of these parties have to deal with this service? Well, for the hardware buyer, right, the person who wants to buy some hardware for the manufacturer, it eliminates all the intermediaries and brokers in that process, which saves them money. And they can go directly to the manufacturer. It's kind of like Uber for manufacturing, on-demand manufacturing. Now, if you've ever tried to contact a manufacturer or a factory, if you have a hardware startup, for example, it's a lot of work and it's not easy and it's a very dated process, right? Sometimes you have to fill out a form and then you have to wait like 3 weeks and then they'll get back to you. But with this, you get a listing of them on demand. I want this, and then it comes back to you. Now, on the manufacturer side, how are they incentivized? Well, it eliminates their marketing costs. Right now, they have to find buyers, so they have to put real money into marketing their manufacturing service. But the smart contracts that SyncFab provides connects them directly to the buyer and guarantees payments. So remember how I said how small businesses usually can't come into this game because there's a reputation system. Well, because of smart contracts, they can, because they can trust that even small players will do their part because there's a trusted blockchain in the middle that is a smart contract that escrows the funds. So you can't just back out of it because there's a 2 of 3 escrow signature, which we'll get into. And they've got their own token, it's called MFG, but I really found their smart contract architecture interesting. So a person has an identity, they'll make a purchase order. Now, a purchase order can consist of so many different features, right? From your ID to your payment terms, whatever, your inspection report, and then they'll make a payment using that. And it goes from in progress, canceled, to completed. A buyer can make a purchase order using a smart contract on an immutable blockchain. So if you've ever worked with the supply chain, that's a new concept. It's never been that easy for a buyer to just make a purchase order without having to deal with at least 2 or 3 intermediaries when it comes to hardware manufacturing. But with this, they can, right? So this provides high quality quotes from the source, on-demand purchasing for the hardware innovators, and a direct connection to the manufacturing facility, which eliminates marketing costs for the manufacturers. Which I think, and they even have an app, which is super cool, and it's a pretty app, et cetera, et cetera. But yeah, that's it's a 13-step process. If we look at the logic for the smart contract. But I think a better way to explain this process is to really build a very bare bones version of an asset tracker. Okay, so let's do that. We'll create a bare bones asset tracker in Remix, which is the Solidity compiler. Now, SyncFab has built their token on Ethereum's blockchain, and it's an ERC20 token. They also are using the Ethereum blockchain to build their smart contracts. So what we're going to try to do is replicate a version of SyncFab's code, but a very simple version of that code. And all this is going to do is it's going to track an asset on a blockchain. So where do we start? So the first thing we want to do if we're going to structure this smart contract is to say that we're going to do the pragma mark solidity and then say what version it is. So remember, the pragmas are known from compilers like GCC. You know, they give the compiler additional information on how to process the given code. It even tells the compiler to use the highest version available using this little mark above that mark. Okay, so once we have that, we can say, let's assume that we have an assets file. Now the assets file will contain more metadata about the assets that we have. Assets.solidity. Okay, so in our asset tracker, so this is what it does. It's a tracker. Now normally we would have a database on a web app that does this, but because this contract will live on a blockchain, nobody owns this. So it's an unstoppable asset tracker, right? Nobody can modify it. Now this asset tracker will contain an ID for the asset, which is a string, which we'll call ID. And we'll create a getter and a setter for this, so we can get and set this whenever we create it, right? So we want to create an ID, and then we want to get it later, so we can verify it. So this ID is going to return a string, or the string, which is the ID, okay? So there's that part. And there's a bunch of different types we could use whenever we're coding Solidity. There's bools, there's static. I've got a list of all the different Solidity types for you in the video description. So when it comes to tracking the data structure that we're going to use, I'm going to say, let's create that data structure. That data structure is called an asset, right? So what is contained in an asset? Well, an asset has a name, right? An asset has a description. It has a source, or we can call it a manufacturer in this case. And we have some Boolean that says, has it been initialized or not, which will tell the rest of the smart contract whether or not it's been initialized. So this is just a simple example. Remember, assets can have so many different features, as we saw before. An asset can have, version numbers. It can have a report, etc. But this is just a very simple example. But in order to store these assets, we're going to create these two mappings that's going to allow us to store asset properties as well as the relation between assets and wallets based on the UUIDs, which are their unique identification strings. So it's a private asset store. So that's the first mapping we'll create. That's going to be used to store assets under their respective UUID. And then we'll have another mapping that maps the asset store from the name, the description. This is for the wallet store, right? So true. What else do we want to say? Manufacturer. And, well, this is to store assets using their respective UUID. And then we'll have another mapping and then we'll have another mapping for the address to make an assignment of an asset to a wallet. So and we can say message.sender UUID equals true. Okay, so that was the first part. Now, for different, there could be a number of real world events that could happen here, right? It's like asset creation, asset transfer, and we're gonna define counterparts for that in this smart contract, right? So what are some possible things that could happen to an asset? Well, one could be the creation of an asset, right? So what would be the parameters for asset creation? Well, we want the address of the account, right? We want its ID, its unique identifier. We want, what else do we want? We want its manufacturer, and we want, I think that's it. Yeah, those are the three. What else do we want? So we want to be able to reject a creation. So we'll say event reject create. Okay. And then we want another one that's going to be asset transfer. And we want one more, which is going to be reject transfer. And this is going to be address account, of course. This is going to be from, because these last two are from. This is going to be a message. This is, we don't need one for a transfer. And then we have a message for a reject, rejection message. And, okay, cool. So there's that. Now we can create an asset. So let me just write out, okay, so now let me write out just a simple function for asset creation, right? So if we want to create an asset, we can say, okay, so using what we've just created before, let's say to create an asset, we need its name, we need a description for the asset, and we need the manufacturer. Now, once we have that, we can write this out. So if the asset stores unique identifier is initialized, then we're going to reject the creation step, saying the sender and the UUID are going to be used as parameters. And what that means is if it's already initialized, asset with this UUID already created. It means it's already been created. Now, once we have that, that's just kind of our failure case. Now, once we have that, then we can say, let's store, if it hasn't been created before, then let's create the asset, the name, the description, true, and the wallet store, right? Because we're going to store the asset. We're going to store it in our wallet, and we're going to create that facturer. Okay, so what this is saying is that in order to, let me just make sure that this is all good. Yeah. So what this is saying is that in order to transfer an asset, we're going to create a function that takes the address of the target wallet along with the asset ID. Okay, and we check those two preconditions, and the asset is, if the asset actually exists, then we don't want to recreate it. But if it doesn't, then we're going to create the asset ourselves. Now, this is the type of function that we would call from web3.js, right? So this is the contract that we would deploy to the blockchain, and then we would use web3.js to then call this contract, specifically create asset, using the name, the description, the manufacturer, okay? SyncFab has their own smart contracts that we could look at on GitHub. They have quite a lot of smart contracts here, but if you're looking for a good source to learn about a production-ready smart contract code for supply chains, definitely check them out. Yeah, so that's it for this video. I hope you found it useful, and yeah,